Welcome to the Bentley Systems training course where you will learn how to design concrete structures using the STAAD Advanced Concrete Design RCDC. Several different types of elements can be designed in the RCDC, including concrete slabs, beams, columns and shear walls, open footings, and pile caps. In this video, we are going to be focusing on designing the concrete slabs in the RCDC. For this course, we're working with a model that's already been created in STAAD Pro, and we're going to design all of our concrete elements in the STAAD Advanced Concrete Designer, the RCDC. In this series of videos, we've shown you how to design the beams, the columns, and also the shear walls. For this particular video, we're going to be focusing on the slabs. Before we can send any model data over into the RCDC, we first need to analyze the model in STAAD Pro. Now, as you look at your sample model, you'll probably notice that no slabs have actually been created in STAAD Pro. The STAAD Advanced Concrete Designer, the RCDC, will read the beam and column geometry from STAAD files. From this geometry, it will identify all of the enclosed regions within the geometry, which could be slabs. This would include actual cutouts and slab areas. The RCDC also works out the spanning type, either one-way, two-way, or cantilevered slabs, and the continuity of each and every slab will be reported. For this particular model, we're just going to go ahead and stay in the modeling mode. We're going to save our model once the analysis is finished, and then we're going to exit out of STAAD Pro. After the model is closed in STAAD Pro, you can launch the STAAD RCDC directly from your desktop. Now, the RCDC can work within the building planner area of STAAD Pro. It can work as a standalone application, or you can import certain model formats such as ETABS or a STAAD Pro model directly into the product, which is what we're going to do for today's training. We're going to name our project. We have to enter a client and an engineer name, and then finally specify our design code. For today, we're going to be using the ACI 318M code, the 2011 version. We're then going to select our STAAD Pro file that has already been analyzed, and we're going to tell the program that we wish to design a slab. Finally, we're going to enter the level of the slab that we want to design, and we're going to select at the top of the structure at the 9-meter mark. Finally, we're going to create our new project, and you're going to notice that STAAD Pro has effectively brought in all of our beams and columns, and every place that was enclosed by a beam and column will be identified as a slab area, and the RCDC has specified automatically the type of span that it was detecting. After the model is imported, that you then need to enter the appropriate information if anything here is not quite accurate. That includes any areas that might be slab depressions or also some cutouts. So let's start with a cutout. We're going to identify slab area S6 over here. You can select it either in the table or right on your graphical area. We're going to scroll over in our data area, and then we're going to enter whether or not it's a cutout. When we say true, then select a different area. It's going to identify that as a slab opening. If you change any of your slab types after they're imported, you should also reevaluate your slab continuity. So we're going to go ahead and say modify, and then reevaluate slab continuity. And it's gone ahead and updated the span types for each of these locations. In addition to that, you can also specify your slab loads and your slab thicknesses. Again, the slabs were not modeled in STAAD Pro, so certain pieces of information need to put directly into the RCDC. So over in the data design area, if we scroll over again, we can enter an imposed load, a live load, and a thickness for each particular section. For most areas, we're going to enter 0.5 kilonewtons per square meter as the superimposed dead load. And for the live load, we'll enter 2.5 kilonewtons per square meter. In the thickness column, you would want to select the thickness for each range, and each range will have a constant thickness. So we'll go ahead and select 305 millimeters for all the areas to start off with. Now, if any of these areas would constitute a slab depression, like say for example, this region was a slab depression, you would want to enter a different thickness for this slab. To do that, you would just enter the appropriate thickness for that slab, and then you may need to modify the top of slab if this does represent a slab depression. So I'll put this down at negative 50 meters. Again, now that I've changed the continuity of the slab, I want to reevaluate the slab continuity. Once this is done, I'm just going to go ahead and save my model again. Now, before we go ahead and design the concrete slabs in the RCDC, we must first specify our concrete slab settings. In the Settings menu, we're going to select Design Parameters. And here we have a variety of different pieces of information we can enter. We can enter the detailing style, and slabs can be detailed with curtailed rebars, that is separate top and bottom reinforcement, or with bent up bar pattern. We can enter our preferred span to depth ratio. Now, the preferred span to depth ratio can be specified for slabs of different continuities. The RCDC will try to design slabs within the preferred thickness, and the design iterations will start from the minimum thickness specified. For thicknesses less than that arrived by the preferred span to depth ratio, the deflection and shear will be checked for the designed flexural reinforcement. For the preferred thickness and more, RCDC will increase the percentage of tension reinforcement to satisfy the deflection and/or the shear check criteria if required. After you specify your preferred span to depth ratio, you can enter your material properties, your detailing options, and your curtailment information. Finally, you're going to enter your available rebar and some optimization parameters for the rebar spacing. After you're done, we can go ahead and click OK. We are now ready to perform the design on this slab. In your toolbar, you're now going to click on the Auto Design icon. Now this will run through the design of each slab, and the STAAD Advanced Concrete Designer can design one-way, two-way, and cantilevered slabs. Each slab is designed for flexure and shear. Now slabs in the RCDC are designed for the imposed load, the live load values input for each slab on the design data table. These values are imported along with the slab properties from the slab parameters specified in the STAAD Pro Building Planner mode if applicable. After the slabs are designed, all the slabs will be designed in one run, and one design result, including suggested slab thicknesses and suggested reinforcement, will be displayed in the data area. If you would like more information or would like to modify any of the information, you can do it on a per slab basis. We're going to highlight our first slab, slab 1, and then click Modify, followed by Design. Now the STAAD Advanced Concrete Designer allows you to design slabs by three methods. You can do the analysis and design, and with this option, the analysis of the slab is done as per the coefficients of bending, moment, and shear for one-way and two-way slabs. Slab loading will be uniform dead load over the entire slab. You can do an only design method, and this option is to be used in case the analysis of the slab has already been done. The design can be performed for values of bending moment and shear force entered directly. And you can also enter the multiple imposed load option. This option is available for one-way and cantilevered slabs only. In this option, you can analyze and design slabs for multiple loads applied along the length, partially or fully on the slab. The load types possible are uniform dead load, point loads, and triangular loads. If you would like to modify any of the parameters, you can do that at this point, or if you would like to stop the modification process, you can click on the can icon. You can also modify the details of the reinforcement. For this, we're going to highlight our slab, then click Modify followed by Detail. Now in this window, you're going to notice that your main reinforcement data is active, which allows you to modify the reinforcement. Here we can enter different diameters of reinforcement and different spacing requirements. If you like your new bar layout, you can go ahead and click on the Accept button to update the reinforcement for that particular slab. We also have the option to copy the design of one slab to some other slabs in the model. So here I'm going to right click after the slab 1 is selected and say Copy Reinforcement. Then I'm going to select the other slabs for which I want to copy this reinforcement to. Once I have those highlighted, I'm going to right click and say Paste Reinforcement. Now you're going to notice that the STAAD Advanced Concrete Designer replaced all the reinforcement where the new reinforcement layout was acceptable. The optimized reinforcement will remain if the new reinforcement did not work under that situation. Now after your design is complete and you're satisfied, you're able to look at your reports and your drawings. Let's start with a general arrangement drawing. We're going to go up to our Reports menu bar item, and then we're going to select the General Arrangement Plan. Now this plan will show the slab and beam generation arrangement drawing, including a beam legend over at the right-hand side to indicate the size of each beam. In addition to that, if we want to select Reports, followed by Text Schedule, we can also get a schedule of the reinforcement for each of the slabs within the model. After that, now I'm going to select Reports in Plan Detailing. And here I can actually get a plan of the detailed reinforcement for each of the slab areas. And finally, I'm going to get a bill of quantities. We're going to go to Reports, followed by Bill of Quantities. And here I'm going to see all of the concrete and the reinforcement that would be required for these particular slabs. In addition to that, if you would like some detailed calculation reports, we can go up to our Reports menu and select Design Summary. In the Slab Design Summary report, you're going to notice that several pieces of information are provided. You're going to see the length in each horizontal direction of the slab. You're going to find your live load and imposed load, the thickness of the slab, the span type, the design code, the grade of concrete, the panel type, the grade of steel, and also your reinforcement results. If you would like some additional information, we're now going to go to Reports, followed by Design Calculations. And you can select any slab you want, or even all of the slabs. And here you're going to get some very detailed calculations to describe the design moment calculations and the shear moment calculations. The design moment calculations will show you that the short spans are positive and negative moments, the long span positive and negative moments, along with the distribution reinforcement. The shear moment calculations will show you the shear design along the short span and the long span of the slab. This would conclude your process for designing concrete slabs in the STAAD Pro Advanced Concrete Designer, the RCDC.